morning, students. During the last classes, we discussed about the nitrogen containing compounds, where we discussed the preparation and properties of amines, and also we discussed about the preparation and properties of benzene diazenyl chloride. And also we have gone for different kind of questions based on the amine and benzene diazenyl chloride. Now today we will discuss a new chapter, that is polymer. The polymers application chemistry, and basically your industrial chemistry. Okay. So in this chapter we will discuss what are the polymers, what are the different kinds of polymers, how the polymers are being classified on different heads, and also we will discuss how to synthesize the polymers and the different applications of polymers. We know today's era is basically called the era of plastic, and plastics are the best example of the polymers. In our household furniture, we are using the chairs, tables, different kind of household furniture, different kind of toys, and even if we are using this polymer kind of materials in your television, refrigerators, washing machines, computer cabinets, so different kind of household equipments, furniture, also made up of the cabinets, made up of the different kind of polymers, like fibers, like different kind of plastics, thermoplastics, thermosettings, resins, and today's class we will discuss how these polymers are being classified and how can you use them, how to synthesize them. First of all, if you see polymers, if I see polymers, this you see is the word poly, okay, and this is equal to what more. Poly means what? Many, more are parts. So many parts. When many parts join together, you are getting what polymer. So many parts comes from one part. So when one part becomes many part, it becomes what polymer. Simple example I can take. See, if I have suppose CH2 CH2, this is called what? Ethene. What? Ethene. If I take n number of ethene molecules, and remember this n at least 10,000. At least 10,000 n. So if I will go for polymerization, I will get what? CH2 single bond CH2 n. So this is called polythene. Polythene. So CH2 CH2, the single part, one part. When the CH2 up to n numbers, 2, 3, 4, 5, 6, 1, 8, and up to at least 10,000. Normally the number of units at least must be 10,000. Okay. So when joined together, I am getting a big giant molecule, and this big giant molecule is called what? Polymer. Okay. Ethane, from ethane I get one polyethylene. So what's a polymer? A polymer is a big giant molecule of high molecular weight, which is formed by the combination of large number of small molecular weight, small molecules by a process called what is polymerization. Okay, so polymers are the big giant molecules formed by the combination of a large number of low molecular weight small molecules, and the low molecular weight small molecule is called what? Monomer. So the small unit here, this is called what? Monomer. Monomer is called what? The polymer. And remember, in a polymer, the monomer unit is must. Okay. Now, because the polymers are the big giant molecules, large molecules, they can be also considered as macromolecules. Because the polymers are the large molecules. But there are molecules are there which are very large, called macromolecules, but are not polymers. For example, chlorophyll. Chlorophyll is a large molecule, contains near about 55 carbon atoms. See 55. Okay, but there is no small unit. There is no monomer unit. Only one molecule. One molecule, large molecule. Up to see 55. So this is called what? Only macromolecule. Or when I am taking polythene, it is a large molecule. But this large molecule is formed by the combination of small monomer unit. So polythene is a polymer and a macromolecule. But a chlorophyll is a macromolecule but not a polymer. That means see, all polymers are macromolecules, but all macromolecules are not the polymers. Clear? Clear the idea about polymer? Now we will go how to classify these polymers. So polymers are being classified on different heads. For example, polymers are classified. See, classification of polymers. Number one, on the basis of origin of source. Number two, on the basis of molecular structure. Number three, on the basis of intermolecular forces. Number four, on the basis of synthesis. Number five, on the basis of degradability. Number six, on the basis of types of monomer units. So these are the 6 types of classification based on the classification of polymers. So these are the different types of classification of polymers. So we'll discuss one by one. First of all, on the basis of origin of source. On the basis of origin, the polymers are of two kinds: natural polymer and synthetic polymer. Okay. On this basis, you have natural polymer, and what synthetic polymer. So natural polymer is what the polymers which we find in the nature. That means basically these are the polymers which we are finding in the animal and plant. So for example, if I think about the natural rubber from the rubber tree is what? It's a natural polymer. Cotton, silk are the natural polymers. And when we think about your proteins, nucleic acids are the natural polymer of the animal kingdom. Okay, so proteins, nucleic acids, your carbohydrates, cellulose, starch, rubber are the natural polymers which are found in the nature from plants and animals. Now what are synthetic polymer? Are those which we are synthesizing in the laboratory or we are manufacturing in the industries are called the synthetic polymers. For example, polyethylene. Polyethylene, you know, polyethylene is one of the most widely used carry bag. Nowadays it become a bane. Okay, but till date we are using polyethylene. Polyethylene, PVC, polyvinyl chlorides. We know the PhD, the sanitary pipes, household pipes for the water supply. PVC, polyvinyl chlorides, polyethylene, okay, nylon, aniline, okay, polyester, bakelite, all are the synthetic polymers. Okay, so those polymers which we are finding in nature, that is in the plant or animals, are called the natural polymers. Okay, and those polymers which we are synthesizing in the laboratory or manufacturing in the industry are called the synthetic polymers. Okay, so the synthetic polymers we have developed to meet the need of the people. So those polymers, for example, your silk and cotton. Cottons are the natural polymers available, but to meet the clothing requirement of the human beings, we need some extra materials that we have discovered. The polyester, nylon, okay, are the synthetic polymers. Clear? Now classification on the basis of molecular structure. On this head, the polymers are of three kinds. Okay, one is what? Linear polymer, branched polymer, and what? Cross-linked polymer. So linear polymers, where the monomer units are joined together to form a long straight chain of monomers, is called what? Linear polymer or linear chain polymer. Okay, so if I have the M is the monomer attached to M the monomer M, the monomer N, and N M so on. This is called what? The linear polymer. That is it. The monomer inertia are joined together to form a long straight chain of monomers. Okay. Now branched polymer. Here what? Here the polymers is having a straight chain as well as a branch chain. Now here I have M. Again what we here M. So here is a straight again branch. So those polymers which have a straight chain as well as a branch chain are called branch polymers. Okay, and cross-linked polymers are those where the monomer inertia are joined together to form different chains which are forming a three-dimensional network-like structure. That is called cross-linked polymers. Okay, and this is one chain suppose. Again one. Okay, so they are called cross-linked polymers. So those polymers where the monomer inertia are joined together only to form a long straight chain are called straight chain polymers. And if it is having a chain as a branch, we call branch chain polymer. And if the monomer inertia are joined together to form a three-dimensional network-like structure, which is called cross-linked polymers. Okay, next. And one thing you remember here, when we are thinking about the linear polymers, straight chains. So here the monomer inertia are tightly joined to each other. So next, on the basis of intermolecular forces. On this basis, the polymers are of four kinds: elastomers, fibers, thermoplastics, and thermosettings. Okay, so elastomers are those polymers where the intermolecular forces is very less, and this kind of polymers can be stretchable. If you apply force, the polymer can be stretched. Okay, and if you remove the force, again they can be reshaped. Okay, for example, natural rubber. Okay, rubber are the elastomers. Buna S, Buna N are the elastomers. Okay, now fibers are the polymers where the intermolecular force is very high between the monomers. Okay, and they are strong. These are strong. For example, polyesters, nylon, okay, are the fibers. Now thermoplastics are the polymers which become soft on heating and hard on cooling. The intermolecular force is in between the elastomer and the fibers. Okay, example polyethylene, PVC, PTFE, etc. Okay. Now thermosettings are those polymers which once set cannot be reshaped. Okay. Now bakelite. Okay. So elastomers are the polymers having very weak intermolecular force of attraction between the monomers. Okay, and here the polymer can be stretched by applying the force, and if you remove the force, they can be reshaped. Okay, and you got rubber, so basically natural rubber. Buna S, butadiene styrene rubber, here buna N. Then fibers are having high interlocal force of attraction between the monomer units. Okay, and they also exhibit hand bonding. Okay, example polyester and nylon. Third practice becomes soft on heating and hard on cooling. Okay, the force of attraction is in between the elastomer and the fiber. Okay, polyethylene, PVC, PTFE or Teflon, and thermostatics are the polymers which can be once set, they cannot be again reshaped like bakelite. Okay. Now on the basis of synthesis, on the basis of synthesis, the polymers are classified into two categories. One is what? Additional polymer. And what? Condensational polymer. Okay. So additional polymers are those which are formed by adding the large number of monomer units which are basically unsaturated in nature to get the polymer. Okay, so when a number of monomers which are unsaturated in nature are being added, we are getting the polymer. That is called what additional polymer. Okay, so now your CH2 non-bond CH2. If I take your N molecules, and you get what N CH2 CH2 polyethylene, ethene into polyethylene, which is called what the additional polymer. Simply the monomer units are being added. But condensational polymers are, for example, here your polythene, polyvinyl chloride, polytetrafluoroethylene, etc. Okay. Now condensational polymers are those which are formed by the combination of different monomer units with evolution of small molecules like water, alcohol, etc. So two monomer units are combined with evolution of the water molecule or alcohol, that is called condensation polymers. For example, nylon 6,6. So this nylon 6,6 is a polymer of hexamethylene diamine and terephthalic acid. When these two molecules will combine, one water molecule will remove and will get a monomer unit. Then after that monomer unit will combine to give the polymer nylon 6,6. Okay. So additional polymers are the polymers where simply the unsaturated monomer units are being added, and condensational polymers are those where the monomers are added with evolution of water molecule or alcohol molecule or any other simple molecules. Clear? Now number 5. On the basis of degradability. So polymers are normally not biodegradable, most of the polymers, but some polymers are there, very few which are biodegradable. Okay, so on the basis of whether can be decomposed or not, the polymers are of two kinds. Okay, what is bio non-degradable, and what are biodegradable. So those polymers which are not decomposed by the microorganisms are called what? The bio non-degradable polymers. Polythene, polyvinyl chloride, Teflon, nylon 660, terylene, polyester, all are the bio non-degradable polymers. And those polymers, this is a recent topic. Those polymers which can be decomposed by microorganisms are called biodegradable polymers. Okay, for example, next now. So this is the summary of this classification of the polymers. Let's see, polymers are classified into 6 categories on the basis of source, structure, molecular forces, synthesis, degradability, and monomer units. Okay, on the basis of this source, already we have discussed natural and synthetic. Natural examples are starch, protein, silk. Synthetic are polyethylene, polystyrene, PVC, polytetrafluoroethylene. Okay, and now based on the structure we have discussed already. It can be linear, branch, or cross-linked. Okay, linear monomer units are joined together in a straight chain, branch, a straight chain with branch, cross-linked with 3-dimensional structure. Linear example HDFE, high density polyethylene, okay, nylon and PVC. Branch LDP, low density polyethylene and starch, cross-linked by bakelite. Okay. Now on basis of molecular process, the polymers are elastomer, fiber, thermoplastic, and thermosetting. The elastomers are rubber, like natural rubber, Buna S, Buna N. Okay, and then fibers, polyesters, nylon, thermoplastics like polyethylene and PVC, thermosetting like bakelite. Okay. Naturally, on basis of synthesis, additional polymer and condensational polymer. Additions like example would be polythene, Buna S, Buna N, and what is like nylon, bakelite are the condensation polymer. Nylon 6 is there, nylon 6 there, nylon 610 there, nylon 26 there. Okay, different kind of nylons are there. Okay, now on the basis of degradability, it can be biodegradable like dextron, like PHBB, and non-degradable like polyethylene and polyvinyl chloride. And on the basis of monomer units, it can be homo or copolymer. Homopolymers, that means it contains same kind of monomer units, polyethylene, PVC, PAR, etc. and contains different kind of monomer units like copolymers, like nylon 66 or nylon 610, nylon 6 order. Okay, so these are the different kind of polymers. In the next class, we will discuss about how to synthesize the polymers from this monomer units and what are the uses of specific kind of polymers. Okay, thank you.